885 words, within the 855-945 target range. Here's the finished script. Right now, deep inside your brain, a protein called tau is quietly unraveling, twisting itself into tangles inside your neurons, then jumping to the next cell over. The researchers who first tracked this process admit they have no proven way to switch it off. It's happening in the exact region you rely on to remember this video tomorrow, and you can't feel a single moment of it. But by the end of this, you'll know the one rule that might actually slow it down. Tau isn't some foreign invader. It's a protein your own neurons make on purpose, a scaffold that holds their internal transport system together like rebar inside concrete. Under normal conditions, it does its job quietly and you never think about it. But in a stressed, aging, sleep-deprived brain, tau starts to fold the wrong way. It stops supporting the neuron and starts choking it from the inside. And here's the part that should unsettle you. This isn't isolated to one spot. Once tau misfolds in your entorhinal cortex, the doorway to your memory, it doesn't stay put. It travels, neuron to neuron, circuit to circuit, silently rewriting the wiring you used to hold onto your own life. And it's not waiting for old age to start. Studies on brain tissue show the earliest misfolded tangles can appear decades before anyone notices a single symptom, sitting there spreading slowly, long before you'd ever think to worry. Picture a single neuron as a tiny cable car running along a track made of tau scaffolding. When tau misfolds, it doesn't just collapse quietly. It grabs onto healthy tau nearby and forces it to fold the same broken way, like one bent domino tipping the next. Then, at the synapse, the microscopic gap where one neuron passes a signal to another, the misfolded tau crosses over. It rides the same pathways your brain uses to learn and remember, hijacking your own communication network to spread itself deeper in. Researchers call this transsynaptic spread, and brain scans confirm it follows a strikingly predictable route, a staged march first mapped by the pathologist Heiko Brock. It starts small, deep in the memory center. Left unchecked over years, it climbs outward toward the regions that let you plan, focus, and reason. You are not imagining the fog. Something is physically moving through you, one synapse, one connection, one memory pathway at a time. Here's the part that should really bother you. Pharmaceutical trials have spent billions trying to build an antibody that clears tau before it spreads. Most have failed outright. A few have slowed decline by a matter of months, not stopped it. The scientists who mapped this staged spread will tell you, off the record, that once tau begins jumping between neurons, current medicine cannot fully arrest it. That's not a gap in effort. That's the honest edge of what neuroscience currently knows how to do. The experts who discovered the mechanism are, right now, watching it happen in real time in their patients with no switch to flip. Now here's where it gets counterintuitive. You've probably been told the fix is to keep your brain busy, puzzles, learning a language, staying mentally sharp to protect it. But newer research on neuronal activity found something uncomfortable. The neurons that fire the most are often the ones that release and spread tau the fastest. Activity doesn't just use your brain. It can accelerate the very mechanism damaging it. This doesn't mean stop thinking. It means the advice you were given is incomplete, and chasing constant mental stimulation without the other half of the equation may be quietly working against you. So what's the other half? It comes down to a window most people sleep straight through without knowing it exists. During deep, slow-wave sleep, your brain activates something called the glymphatic system, a wash cycle of cerebrospinal fluid that physically flushes waste, including misfolded tau, out of your brain tissue. This flush is concentrated almost entirely in your first full sleep cycle, roughly the first 90 minutes after you fall asleep. High performers who understand this treat that opening window as sacred, not 8 hours in general. That specific first stretch of deep sleep, protected and undisturbed, because that's the shift when your brain's cleanup crew does most of its work. Miss it, fragment it, or drink through it, and the flush is measurably weaker. This is the rule researchers keep circling back to in the data, even without a drug. Protect the first 90 minutes, and you protect the clearance system tau depends on you neglecting. Tonight, that means getting into bed before your usual scroll, not after it. Drop your room to around 65 degrees. Cold rooms deepen slow-wave sleep. Skip alcohol, which suppresses exactly the sleep stage that clears tau, even though it feels like it knocks you out faster. No screens in that final half hour, since blue light delays how fast you drop into deep sleep in the first place. You're not trying to sleep more. You're trying to protect the first 90 minutes you already have. But tau isn't working alone in there. There's another structure, deep behind your eyes, quietly deciding whether it clears the debris tau leaves behind, or seals it in for good. Save 2home/jarvisadmin/brainfuel tau script TXT.